Hello everyone, I hope you're doing well. I wanted to go over one of the exercises that will be on the exam this coming Thursday, April 30th. That's 6.4 Roman numeral 2, valid or invalid. It's in the assignments given. Here you're supposed to say, using a truth table, whether they're valid or invalid. So the first problem has only one variable. R implies R, therefore R. And so I've set it up to the premise, double slash to separate the premise from the conclusion. Since there's only one letter, under R you put true, false, true, false, true, false whenever you see it. Then you have to solve for T implies T on the first row. Let's just number these. T implies T is T. F implies F is T. Okay, and then you'd have to take this as the premise, and does it imply this? So T implies T is T. T implies F is F. So what do we know? On that second row, this has been proven invalid. Why? Because we found one row where there was true in the premise and false in the conclusion. So that combination, true in the premise, implies false in the conclusion, is always invalid. Let's try number 2. Number 2 says that you have P is P triple bar, not N. Therefore, N or P. Okay, so I don't mind numbering the columns here. So P, under P you would have 2 truths, 2 falses. Under N, true, false, true, false. Under N again, true, false, true, false. Then under P, as it was the first time, true, true, false, false. I can do not N right off, that's the order of operations. Not T is F, not F is T, not T is F, not F is T. Equivalence means if and only if, or if they're equal to one another. Think of identical to. T identical to F? No. T identical to T? Yes. F identical to F? Yes. F identical to T? No. So you'll see that on 2 of the 4 rows they're T, and the other rows they're F. True or true with a disjunction, that operator, only one has to be true. True, also true is true. True or false is true. False or false is false. Now, in order to get the values for under the double slash, we're going to use column 2 as a premise, column 6 as the conclusion. So this one, and then this one. So false implies true is true. True implies true is true. True implies true is true. False implies false is true. So that is a valid argument. Why? Because we could not locate a single row on which the premise was true and the conclusion is false. Had we found such a row, that's the very definition of invalid. So that's how that works. Okay, now we're going to move on to the next exercise. Again, we're going to do 6.6 Roman numeral 1, and you'll notice that these are argument forms. And it turns out that there are 8 altogether, 6 valid and 2 invalid. Okay, so let's look at the first one that he goes over. That is modus ponens. Just a Latin phrase meaning method of putting. Doesn't make complete sense, but it works like this. If P, then Q, and P, there's the putting part. You put the second premise rather than negating it, that's where it comes from. Therefore Q. That's a valid form. The way I always used to do it, not try to memorize if P then Q, P so Q is valid. That you could do that rather easily. But substitute language. If it's raining, then the streets are wet. It is raining, so lo and behold, the streets are wet. So the 2 premises imply the conclusion. That's a valid form. Modus tollens is another one that he uses. Standard. Modus tollens, method of taking in the Latin. If P then Q, negate the Q or the consequent part, and then negate the P. You could remember it again, but again, I prefer language that always worked for me. If it's raining, then the streets are wet. The streets are not wet, so it's not raining, because there was a guarantee that if it was raining, they'd be wet. So if we look outside and they're not wet, then it's not raining according to this. We're not saying that that's sound or anything. All that's true. There could be other ways they can be wet, obviously. But that form is a valid form. So both are valid forms, modus ponens, modus tollens, method of taking. In the second premise, you negated the second premise or took it. That's the reasoning behind the name of it. Then you have disjunctive syllogism. disjunctive syllogism, we just think of an either or. Okay, so P or Q, P is true or Q is true. And then you have not P, therefore Q. So, it's going to be sunny or it's going to be rainy. It's not sunny, therefore it's rainy. You offer up two disjuncts, in this case P or Q, saying that one of them is guaranteed to be true. That guarantee makes the rest follow. So if one of them is not true, then the other must be. You can have peas or carrots. Oops, we ran out of peas, so you still can have carrots. So that's the disjunctive syllogism. Notice it's only valid when you negate one of the disjuncts in the second premise, and then you affirm the other. If you affirm one of the disjuncts and then negate the other, that would be invalid. Okay. Then you have hypothetical syllogism. I'm going to squeeze that in down here. I'm going to abbreviate it. Hypothetical syllogism. You'll see it. There's an order that they're in here. I think I am going by the correct order. But if P then Q, and if Q then R, therefore if P then R. Okay. So, if it's raining, then the streets will be wet. If the streets are wet, cars will slide on the pavement. So if it's raining, cars will slide on the pavement. Forgetting about the truth of any of that, what makes that valid is that the antecedent of the first premise, the P part, becomes the antecedent of the conclusion. And you'll notice the consequent of the last premise, the second premise, becomes the consequent of the conclusion. I like to say they're tightly linked premises. The consequent of one premise to Q becomes the antecedent of the next, and so forth, and that's what makes that a valid form. It can't miss. It's called pure hypothetical syllogism. We don't need the pure part. We'll just call it hypothetical syllogism, or HS for short. Okay. There's several more to go, and some of these are rather longer formulas. One of them is called constructive dilemma. Okay, so in this case, a constructive dilemma is really a conjunction of two conjuncts, or two parts. So the first is P implies Q, and then you'll notice the end, so it's a conjunction, and R implies S. Then you have the second premise, P or R. P is true or R is true. Well, some of you thinking ahead will see that if P is true, then Q would follow. If R was true, then S would follow, and that's just what I can derive from that. I can derive Q or S from that disjunction. How? Let me go over it again. Both of these are true according to the first premise. P implies Q is true, and R implies S is true. Okay, so if P then Q, and if R then S. So, if you're given P or R, you don't know which one, but at least one of them is true, right? If P, for example, happened to be true, then Q would follow. If R happened to be true, then S would follow. So, one or the other being true, then it must follow that the consequent of these, one of those consequents must follow, either the Q or the S, and so that's why the conclusion is the way it is. Constructive dilemma, as opposed to destructive dilemma, where you, in effect, negate, as you'll see, one of the, you'll negate the consequent of the one of the formulas. So, if P then Q, and R then S, now we have not Q or not S, right? One of those is bound to be true. Then we're allowed to deduce not P or not S, you see, right? So why? This says if P is true, then Q is true, and if R is true, then S is true. Then we're being told that not S is true, or not Q is true, or not S is true. If not Q is true, that goes to the consequent of the first conjunct. If not S is true, that goes to the consequent of the second conjunct. Therefore, according to thinking like Modus Tollens now, if the not Q is true, then you could say not P. And if the not S was true, then you could say not R. So not P or not R. I'm sorry, I made the wrong letter there in the not R. I wrote down R implies. No, I did it right. Q is not S, so not P or not R. That's what. Yeah. Okay. So if you negate the second part, then you can negate the first conjunct. So negating Q, if you negate the Q part, then you're allowed to negate the antecedent. If you negate the consequent part here, or the S, then you're allowed to negate the antecedent there. So that's destructive dilemma. You're taking away instead of constructive dilemma. Now there's two invalid forms that he gives you. kind of to watch out for. And they are affirming the consequent and denying the antecedent. We were told, remember, that the invalid forms, he calls it AC, affirming the consequent. So if you said if P then Q, Q, therefore P, that would be the invalid form. If it's raining and the streets are wet, the streets are wet, therefore it's raining. Well, you can't make that inference, that's not the same thing. You're affirming the consequent right here, and that's what makes it invalid. Remember, I'll put I for invalid so you don't get confused. The valid form was like this. P implies Q, P, so Q. Remember when we did modus ponens. So we don't call it invalid modus ponens, we just call it affirming the consequent. And then you have also, going along with that, denying the antecedent. Okay, so denying the antecedent, you'll notice, is what happens when you deny the P rather than the Q, or you're just denying the antecedent. So if P then Q, not P, therefore not Q. Well, what makes that is invalid, again, if it's raining and the streets are wet, it's not raining, therefore the streets are not wet. You're denying the antecedent of the first premise. It's only valid when you deny the consequent, as you remember with modus tollens. So we call this DA, denying the antecedent. Remember, this was valid when we did this. If P then Q, not Q, so not P. I go through it in 3 dots, but okay, not P. So that's a valid form. Okay, so those are the 6 forms, and we'll pick up from there. Okay. Hi everyone, so 6.6 Roman numeral 1, it says interpret the following symbolized formulas in light of the 8 argument forms, and then say whether they're valid or invalid. Okay, so if you take the first one there, the first one to do without the star, that is, you has number 2, S implies F, and F implies not L, therefore S implies not L. And you're being asked to say what form that is. Well, that's a hypothetical syllogism, so just put HS. S implies F, F becomes the antecedent. So, pure hypothetical syllogism. It also happens to be valid. Okay, 3, what form is it? Or if it's no form, just say it's invalid. It says A is true or Z is false. And then it says Z is false, so therefore A is true. That's the wrong form, or that's an invalid form. So we just say invalid. It's not, it has the appearance of a disjunctive syllogism because of the or in the first premise. But what makes it invalid is that the second premise, the not Z, or Z is false, affirms one of the disjuncts instead of denying one of the disjuncts. And so it's invalid. Okay. Number 5, skip to that, we're told not N, or N is false, negation N implies T, therefore T. Well, it doesn't matter what order you do the premises in to check the proof. If N is false, then T is true, and N is false, so T is true. That is valid, and it's modus ponens, it has that form. If the antecedent, then the consequent, and the antecedent, therefore the consequent. In this case, the antecedent is a negative, that might throw you off, but forget that part. It says if this antecedent part of what comes before the horseshoe, then what comes after the horseshoe is the case. And the antecedent is the case, so therefore the consequence is the case. Okay. 6 says M is true or B is false. Not M, therefore not B. Okay, well, a disjunctive syllogism says that one of those must be the case. If it's you're going to negate one, M or not B, not M negates the M, so since one of them must be the case, M is true or B is false, and not M is not one of them, so then not B must be it. So that's a disjunctive syllogism. Of course, it is valid. Okay, back to where are we on now? We're going to do 8 and 9. Okay, so 8, W implies not M. W is true implies M is false. Not M, therefore W. Well, that's affirming the consequent, it looks like to me, and that can't be valid. For that to be valid, we would have had to affirm the W in the second premise, but it's an invalid form, you'll remember, to affirm the consequent, if you look back at that. Not B implies not L, B is false implies L is false. G implies not B, therefore G implies not L. Well, if we read that from the second premise first, G implies not B and not B implies not L, then G implies not L. Don't be thrown off by the order, that's what he's trying to do, is throw you off a little bit, but that's a hypothetical syllogism, and that is in fact valid. Okay, so, the other ones were fallacies and were not valid. Okay, so that's all for that particular exercise. Then we'll go on to 6.6, Roman numeral 2. Okay. Hello everyone, we're back to the exercises, and this time 6.6, Roman numeral 2. It says translate the following into symbolic notation and then interpret them in light of the 8 argument forms. So you have word problems here. That's basically the sum and substance of it. Not a great big problem. Okay, so in this case, if Michelangelo painted the ceiling of the Sistine Chapel, M, then he was familiar with stories of the Old Testament. Okay, then F. Those are the two letters given. You'll notice M and F. Michelangelo was familiar with stories from the Old Testament. So F. Therefore M. Right away I can see that that's affirming the consequent, and that will be invalid. Okay, so that's not a valid form. That's an invalid form of modus ponens, if you will. So that's not going to work. Number 3 says it's a longer formula and has the appearance of a constructive dilemma. And how does it go? It says if you enter the teaching profession, E for enter, then you will have no money for vacations. Then not M. Okay, and then you're going to see an and there. And if you do not enter the teaching profession, then you will have no time for vacations. Okay, so it's going to be not T, the time. Okay, since you must either enter or not enter the teaching profession, E or not E, wedge, not E, sorry, E or not E. Therefore, you can come up, that must be the case that not M or not T, which would be, it follows the you have no money or no time for vacations. What kind of form is that? You'll notice it's what we did a few moments ago, constructive dilemma. I'm just going to put CD there for constructive dilemma. How? You have a conjunction in the first premise, that's the hallmark of a constructive dilemma. Then you have in the second premise the antecedent of one of the conjuncts or the antecedent of the other. And if you take one, since one of those must be true, one of those consequents must be true. Okay, so that's number 3. Number 5, that's rather quick, so we can do it without erasing. Not N and not N implies T, so T. Well, I can tell what that is. Not N implies T, therefore T. Well, read from the second premise first. N is false, then T is true, and N is false, then T is true. That is a modus ponens, and it's a valid form. Right, Plato? Yeah, great, Plato. Okay, good. And then number 6. I can erase a little bit. And number 6 says, if the sun is a variable star, then its energy will drop drastically at some point in the future. So, if S, then E. And if its energy drops drastically at some point in the future, then the Earth will become a giant ice ball. If E, then G. Therefore, if the sun is a variable star, then the Earth will become a giant ice ball. S implies E implies G, S implies G. This is a hypothetical syllogism. It has the correct form for one. Okay. Now, I want to then take two more from 6.63, and the job there is to say whether these are constructive or destructive dilemmas. Okay, let's see what they are. Constructive dilemmas or destructive dilemmas. The first one has the following form. Okay, if we build our home in the valley, it will be struck by floods. Okay, so if V, then F. And if we build it on a hilltop, the dot there, if we build it on a hilltop, then we'll be hit by lightning. Okay, since we must either build it in the valley or on a hilltop, then our home will either be struck by floods or hit by lightning. So V, or floods, or hit by F or L. Well, you're being asked to say whether it's constructive or destructive. That's a constructive dilemma, because we're not negating anything. We're just saying that one of these implications will be true based on the second premise that guarantees that the V or the H will be true. So that's a constructive dilemma. 3. Okay, we're going to do 6.6 Roman numeral 6.6 Roman numeral 3, number 3. And this works like this. If psychotherapists must respect their clients' right to confidentiality, then C, then they will not report child abusers to authorities, not R. And if they have any concern for the welfare of the children, you're being given W, you're allowed to use W, then they will report them. The second premise has a period there, so you know the first premise has ended. Psychotherapists must either report or not report them to the authorities, so R or not R. Well, where does that stand in relation to what we see up above? R is the negation of not R, so we can tell this is a destructive dilemma, so that entitles me to say not C. If I'm negating the consequent there, I'm allowed to negate the antecedent. Not R, the second disjunct, is the negation of the consequent of the second conjunct here, and that allows me to negate the not W. So that argument has to be a destructive dilemma, and a valid one at that. Alright, so if you try some of those other problems, this should drive that home. And do the reading, study the argument forms, and you should be good. Alright, see you soon. Bye-bye.